Now let's practice. We want to determine if this is acidosis or alkalosis. The primary problem either being respiratory or metabolic. So your first one, 7.30 is your pH. Your PaCO2 is 50, and your bicarb is 24. As you can see, the pH is 7.30. This would indicate, that this is acidosis. Now we need to determine what the primary problem is. Your normal bicarb is 22 to 26, so your bicarb falls in the normal range. Your PaCO2 is elevated because your normal PaCO2 is 35 to 45, and this PaCO2 is 50. So your primary problem is respiratory. Therefore, this would be respiratory acidosis. Let's move on to number 2. Do we determine that this is alkalosis or acidosis? With a pH of 7.25, we can easily assume that this is acidosis. Now, with a PaCO2 of 44, which does fall into the normal range, we can assume that this is not respiratory. So let's take a look at our bicarb. Our bicarb is 18, which is low. It should be 22 to 26, and this is 18. So we can say that this is metabolic acidosis. Our last example has a pH of 7.47. This would be alkalosis, because our normal pH is 7.35 to 7.45, and anything above 7.45 is alkalotic. Your PaCO2 is 27, which is low, so we have a loss of acid. And your bicarb is 19, which is also low. It should be 22 to 26. However, your PaCO2 is going to be further off than your bicarb. So we can look at this and determine that it is an uncompensated respiratory alkalosis. Now, things that we need to remember. Remember that respiratory compensation is rapid, where metabolic compensation is much slower. Also know that it is extremely rare for the body to overcompensate. The metabolic portion of acid-base balance compensates for the respiratory portion when the respiratory portion fails, and vice versa. So compensation for acid-base imbalance, respiratory acidosis is compensated by metabolic alkalosis. Respiratory alkalosis is compensated by metabolic acidosis, and vice versa. We want to look at these and practice a little bit. Compensated respiratory or metabolic acidosis or alkalosis. So let's take a look and practice. You'll note on example 1, the pH is normal. Your PaCO2 is high, it is 60. And this is compensated by your bicarbonate, which is elevated as well, 32. Your PaCO2 is much more off limit or out of whack there. So that would indicate a respiratory factor. So you could easily say that this is a compensated respiratory acidosis. You want to look to see which unit, either your PaCO2 or your bicarb, which one is furthest out of range. This identifies your primary problem. Let's look at our second example. Your pH is 7.42 with a PaCO2 of 50 and a bicarb of 33. Okay, so we know that this is compensated because our pH is within normal range. It is on the alkalotic side of normal. And our bicarb is much more elevated than our PaCO2. So this would be a compensated metabolic alkalosis. Example number 3, your pH is 7.35 with a PaCO2 of 30 and a bicarb of 16. This is definitely compensated because your pH is 7.35, which is barely in the normal range. And it is on the acidotic side. Now, do we want to determine whether this is metabolic or respiratory? Your bicarb of 16 is much further out of line than your PaCO2. So that would make this a compensated metabolic acidosis. Now, for example number 4, your pH is 7.45, your PaCO2 is 27, and your bicarb is 18. This is definitely more alkalosis because your pH is 7.45. And when looking between your PaCO2 and your bicarb, your PaCO2 is more out of line. That would make it a compensated respiratory alkalosis. And that pretty much covers it for acid-base imbalances.